the question in front of us. This question is from binomial theorem. So I hope the question is in front of your screen. So the question says, if the sum of the binomial coefficients in the expansion of in the bracket x squared plus 2 by x cubed to the power n is 243, the term independent of x is equal to. Okay, so our binomial expansion is something like this. So if I want to break this up, I can say that this is equal to nc0 x to the x squared to the power n 2 by x cubed to the power 0 plus nc1, and it's going to okay, nc1 then x squared n minus 1 2 by x cubed to the power 1, and from here it is going to continue for a very long period of time. So we want to find the sum of these coefficients, which is in turn something which looks like this. The sum of the coefficients is nc0 plus times to the power 0 plus nc1, then we have 2 to the power 1 plus nc2 2 to the power 2, and this goes on and goes on. Now there's one more thing we can do about this. So if we look at this expansion, which is this, so this can be written as summation of r from 0 to n ncr x square n minus r and this. So this is the general form of this binomial expansion. When we're talking about the sum of the coefficients, which is this can be achieved if we put the value of x as 1. So if we put the value of x as 1, here we always get something in terms of 1 which varies its sign, and here we get also something in terms of 2 to the power r. So it gives us this form of structure. So our binomial expansion was this. So I put x is equal to 1 in this binomial expansion, and when I do that, we get 1 plus 2 to the power n or 3 to the power n. So the sum of the binomial coefficients in this expansion is this. Now in the question we've been given that the sum, the 3 to the power n which I have got is equal to 243. If you look at the question, it is given 243. So we know that 243 is also 3 to the power 5. So from here we can say that n is equal to 5. So the new binomial expansion after solving this much is, okay, let's write it here. It's x squared plus 2 by x cubed to the power 5. Now we are now asked the term independent of x. So now this is something we've got the value of n. From there, now what we want is the value of the term where x, the power of x, is 0. Okay, now let me again write the general expression of the rth term. So the tr here, okay, just a minute. The tr here is nc r minus 1. Then we've got x squared to the power n minus r plus 1, and we've got this. If we write our rth term here, the value of n is 5, so we want to keep a note of that. Further, if you look at the power or the exponent on top of x, so that is 2n minus 2r plus 2, and here from here we get minus 3r plus 3. If we simplify this little further, what we get is 2n minus 5r plus 5. If you put the value of n, which is 5, we get 15 minus 5r. Now in the question we want the term independent of x. So the power of x for independent of x should be 0. What we get now here is then that r is equal to 5, because we need x to the power 0. So the rth term will be the term independent of x. Now the question is very simple, it's nearly done. What we just need to find out is the third term, which will be given by 5c2, and we don't need to bother about the power of x anymore because it's already cancelled out. So what we just are left with is this. If we were to simplify this, what we get is 5 times 4 divided by 2. It can be written as that. because it is 5 factorial divided by 3 factorial by 2 factorial, and it is multiplied by 4. So if you want to simplify that, what we get is 40. So the correct option here is option A. The term independent of x is 40.